working on these on IP-based video systems for over 15 years now, and I kind of want to come and share some of the lessons I've learned, some of the things that have improved, and some of the things we kind of still struggle with today. Once again, I'm Ian Cobb. I'm a IT systems architect. I come with a broadcast background, but I've always been focused on IT and networking. My job is excuse me. I work in a lot of professional sports venues and working with a lot of different organizations, building high performance media networks to bring together not only 2110 but other proprietary formats and converging everything together to build high performance media networks for our clients. The company I work for is named Alpha Video. They're based out of Minneapolis, Minnesota. We've worked on a lot of prominent projects, a lot of sports stadiums around the country, and other fancy projects like the MSG Sphere in Las Vegas. Kind of the topics I want to cover is planning design. A big thing that I love is figuring out documentation. Documentation is a thing we still haven't, we need to communicate about how these systems work, and documentation is an important part of that. Physical fiber planning is typically very, very important with large IP deployments, and then we'll talk about a few things we've learned in the field. What is the media network? Today, as we're moving forward, we're not just building little islands of IP anymore. Most of the time, we want a fully converged network that brings together cloud assets and brings together remote assets. And so we're not just building a little island of IP in a control room. We're connecting remote sites together. We're integrating compute resources that may exist on the cloud, in public cloud or in private cloud or elsewhere. And so when we're building these things, we need to make sure that we're thinking far enough ahead so that we can accommodate future growth as we're building our networks. When you're going through these processes, one of the most important things I like to focus on is a lot of this is not just one person sitting down kind of making out a plan. You need to bring together the human element when you're building these networks, because you're not typically working by yourself. You're working with multiple organizations. So you need to start off with an extensive workflow discovery. You need to configure out your contribution sources, your destinations, how you're going to remotely access these things. And you have to make sure that you're communicating with the client or the customer on how do we accommodate the security requirements of the organization and still meet our workflow objectives, because sometimes those things can conflict with each other. One of the biggest, most important things, sometimes you get to design the network, sometimes you have to work with customer IT. So bringing together all of your different infrastructure, your firewalls, routers, and making sure that you have a plan that not only accommodates the needs of the production, but meets in with the security posture of the organization that you're working with. The more you communicate, the more you document, normally the easier time you'll have working with your client. You need to figure out what type of topologies you're going to introduce, what's most appropriate for the application of your system, and then what level of redundancy is appropriate. We have a lot of customers that don't want to make the additional investment in having a fully redundant -7 environment, but you need to think about, how am I going to maintain the system? How am I going to upgrade the system? And then once you kind of consider those things, you'll kind of understand that maybe having a fully redundant network is necessary. And it also allows for stage configuration management and further testing. You got to understand your bandwidth requirements. Make sure that you understand your bandwidth requirements for the real-time hose of data. You also need to make sure that you have the bandwidth for any type of file-based workflows that you may have coming down the pipe. Different types of networks have best effort networks. Most IP networks are best effort, but sometimes you want to introduce police bandwidth to make sure you don't have oversaturated links, and you can do that with software-defined features, so similar to like Cisco IPFM or Arista MCS, or you can just build a completely non-blocking network and let it ride. You kind of have to consider when you're doing switch planning or when you're building architectures. We're not in the days of every single device gets a different port. We're using channelized optics, so we're taking a 100 gig interface and breaking out into 425s, or a 400 gig interface and breaking out into 100 gig interfaces. What that does, it adds a lot of complexity into your physical layer planning. Before, we'd have one device, one port. Now we are having cascading layers where things are fanning out, and it's really important to overinvest in your layer one planning, because once you've built that foundation, it's very, very difficult to change it while the system's running. You have to also consider how your devices are going to register, how device registration and discovery is going to work. Most of that's handled through NMOS, but are you going to use a static RDS? You're going to use SDDNS, and what are the implications of deploying those two different technologies? You're going to have to figure out what devices are going to talk to what, and probably build an ACL matrix so that you don't want to leave your network wide open. When you're doing in your planning phase, it's really good to determine what devices need to talk to what other devices, so that you can start with a focus on security from the inception of your network. Documentation becomes really important. Here's documents that we've had in the past where we have a whole bunch of VLANs and things like that. What we're finding is that the documentation that we have that we started with worked really well in a baseband world, but we are having kind of an additional dimension to how signals flow, and so you're going to have to change how your documentation works. Like I said before, you need to really plan for the future. Make sure you over allocate your address ranges so you can accommodate future growth. Make sure you pre-configure media ports to make future growth easier to implement, and then figure out if you're doing manual multicast address assignment, and make sure you avoid multicast addresses used by other protocols. I've had clients before use address ranges that are used by routing protocols and brought down their whole network. So there's kind of just little things you have to remember when you're planning things out to make sure you have a successful deployment. Documentation is a huge thing. Back in baseband, it was relatively simple. Everything was flat and on different layers, and it was easy to draw in CAD. And now with IP, we have kind of additional layers. We have single devices or single interfaces that may be doing many things at one time. So how do we represent that? Right now, but in the past, we were just in the past, we were just doing simple line diagrams because it was one cable, one signal. But now we have physical connections. We have different asynchronous software workflows that we need to take care of. We have data flow patterns that are happening through different control APIs. And we have to think of logical connectivity and physical connectivity as two separate things, along with how we're authenticating these sources and any types of credentials that we need to store securely and manage through these processes. The different types of documentation you have workflow process maps, configuration diagrams, line diagrams, spreadsheets, and something I've been starting to introduce, and we're building documentation sets is just from the beginning, starting to build a relational database to store all this information, so you don't have to have multiple copies of the same information. You can build a relational database that ties together your sources, your destinations, your devices, their feature licensing, even purchase order numbers, all of that stuff, and bring it together into your overall system design so you can have a more encompassing documentation set. Kind of system examples, building out a simple process map for how we pull in sports data from a sports venue. I like to build these little process maps so we can see we have a sports venue, we have a scoring data feed, how that data gets pulled in from the TV truck and goes through the cloud, and build these nice little diagrams, because at the end of the day, we can't keep all this information in our head, and we have to share it and learn how to communicate this information to other people. Similar, we have line diagrams, which have been around forever. We have spreadsheets for configuring our switch ports, and we can also define device-specific information where we have individual devices and then all of the different multicast addresses that they may consume, whether it's for video, audio, comms, etc. One of the big things that I've learned is you make sure that you always focus on your PTP distribution and make sure that it's as robust as you can afford to make it. There's typically one thing that's always a thing that's discovered late stage in projects is often you may think you're the only, in an organization, the production team may be the only people thinking they're using PTP. But as I found, once you get things plugged in, that you'll have other parts of a sports venue or other parts of a system that are implementing PTP as well. So you may need to consider not only distributing PTP within your production environment, but providing it for other parts of the facility. I've seen lighting control systems that require PTP, HVAC systems that require PTP, elevator control systems. And so if those are all riding on the same network and you're distributing it, make sure that you discover that information and include it as part of your design process. There's a lot of need for audio devices, and make sure that you plan for typically to have a more advantageous port cost. You'll probably still be deploying 1 gig copper switching for audio and ancillary data. And then you need to make sure that there's some devices out there that still kind of have uncommon device proclivities. There's switchers that want in-band NMOS and out-of-band PTP, and there's also devices that will have their NMOS on a tagged interface on the media port instead of just being in-band, so kind of a sideband interface. You have to, and that kind of comes to an issue where not all devices communicate the requirements the same way, and then overinvest in extensive fiber planning, and then build yourself a test kit so that you can do high-speed 25 gig or 100 gig capture. So when you have to go investigate some of these issues, you have that stuff available. One of the things that I've always thought about when we're talking about devices is we don't always communicate what a device requires the same way. When you pick up a piece of food off, or a packaged food item off the shelf. In the U.S., we have this nutrition facts label. In Europe, we have a very similar thing. We don't have that today for our broadcast devices. Different devices support audio different ways. Some devices want 16 mono, some want 2 by 8 channel flows, some want 4 by 4 channel flows. Typically, when you're reading a white paper on it, or a data sheet on a product, that information might not relatively bubble up to the surface and be apparent when you're making the purchasing decision or when you're doing initial planning. There's also different devices that have different PTP requirements and different announce rates. Most of that's been standardized, but you can still come into some weird situations with some when you're bringing together proprietary technologies. How NMOS wants to be delivered, whether it's in-band, out-of-band, or, like I said before, with certain cameras wanting a tagged interface, that kind of sideband interface. One of the things we need to do is standardize how we communicate those elements of a video device, so that when we're making purchasing decisions or when we're going out and checking for device compatibility, we make sure that we're using an apples to apples comparison. And so harmonizing how we communicate about device compatibility or device capabilities is very important. Let's all have any questions? Thank you.